In this demonstration, we show three things: sound localization, speech recognition, and context understanding. The context understanding is handled by our own conversational agent, FrameScript. Here, a specific context is triggered when the robot recognizes a keyword such as main course or drinks. When inside a specific context, all subsequent questions are assumed to pertain to that context. For example, the question, "Any specials?" is interpreted differently depending on the context.
Hey Blinky,
Hi Peter, how are you today?
I'm good.
That's good to hear. Would you like to ask me any questions regarding our menu today?
What drinks have you got?
We have many drinks available. Beer, wine, cocktail or soft drinks.
Have you any specials?
We have a special offer on cocktails today. If you buy one, you get the other for free.
Tell me about your cocktails.
We can make you a range of cocktails such as a mojito, a Manhattan or a margarita.
Would you recommend the mojito?
Absolutely. The mojito is one of my favorites.
I'll have one of those, please.
Certainly.
I will have your recommendation.
That would have to be the margarita. Any more drinks?
No, thank you. What about the main course? What about the main course?
We have a wide range of main courses today, from chicken to land beef.
Any specials? Any specials?
Yes. Today the chef is recommending the roast lamb.
What would you recommend?
I have been told that the chicken is lovely.
I'll have one of those.
Very good.
I will go with a special.
I think you will enjoy that. Anything else?
No, thank you. No, thank you.
No problem. I shall read back your order now. Chicken, lamb mojito margarita.
Here we can see our grasping pipeline in action. Our system allows us to pre-capture point clouds of common objects offline as a way of saving time in online situations. We store these pre-computed clouds in a database for later use. Here we can see the robot assessing the scene and determining what objects, if any, are present. If we detect any objects in the scene that we are interested in, we can extract their partial point cloud and determine, with help from our vision system, if the object is stored in our database. If the object does exist within our database, we retrieve the high-quality pre-captured cloud and align it with the scene. Once an alignment is found and verified, the object is inserted into the scene. We then generate grasps for the object. We use a machine learning-based approach to do this. Once the grasps have been identified, we determine poses that satisfy the grasp constraints and attempt to find inverse kinematic solutions to each of these poses. Finding a successful kinematic solution will result in a grasp attempt. Our grasps are broken up into three stages. Initially, we move to a pre-grasp position, then we grasp the object, and finally move to a post-grasp position. Breaking the process up like this gives us more control over the way the robot executes the grasp. Once we have successfully grasped, the robot moves to a neutral carrying pose, ready to carry out whichever task it is required to next. Okay, Blinky, go to the table, pick up the Coke, and let me know once you've done that.
Okay. So to confirm, I should go to the table. Then I should pick up the Coke, and when I am done, I should inform you.
Yes.
Okay, I will do that now.
Here we are demonstrating the robot's ability to process high-level commands. A PDDL problem is first created and then passed to the ROS planner, where it is interpreted and a high-level plan is generated. This high-level plan is then sent to the dispatcher, and each of the individual actions that make up the plan are dispatched sequentially when the respective previous action has completed. Here, the robot is tasked with navigating to a table, picking up a Coke, and telling us when it has done so.
I have successfully picked up the code.